All right, guys, we are on the back side of day 3 notes for Unit 9, and up at the top it says for a variable to be perfect, the exponent must be divisible by the number in the crack, which is called the index. Okay, aka number in crack. All right, also called a root number. All right, let's go ahead and make a new list because we're going to have cube roots to simplify in our first couple questions here. Okay, so perfect cube root. So we'll go ahead and start with the coefficients. So we're going to go ahead and say 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed equals, and if you don't know this list, you can always generate it in your calculator, all right? Just remember that you're changing the exponent from the front side from a squared to a cube to get perfect cubes instead of perfect squares. Okay, 5 cubed, is 125, and so on. Okay, when we're talking about variables, okay, we have to remember that they have to have a exponent that's divisible by the number in the crack. And since these are cube roots, the number in the crack will be a 3. And so x to the 3rd will be perfect. X to the 6th will be perfect. X to the 9th will be perfect. X to the 12th will be perfect. X to the 15th will be perfect. And they continue on, okay? So remember that if you take the cube root of x to the 3rd, you would just get x, okay? Because there's a 3 in the crack, and 3 divided by 3 is 1, and x to the 1st is just x, okay? If we go ahead and take the cube root of x to the 6th, 6 divided by 3 would be x squared, and so on, all right? So that's how we will do those lists, all right? At the same time, we'll go ahead and make our perfect 4th root, so we would change our exponent to 4, so it would be 1 to the 4th is 1, 2 to the 4th is 16, 3 to the 4th is 81, 4 to the 4th is 256, 5 to the 4th is 625, and they continue on, okay? Now, because these are 4th roots, they have a 4 in the crack, we have to make sure that when we talk about variables, that the exponent on the variable is divisible by 4. So we'll start off with x to the 4th, x to the 8th, x to the 12th, x to the 16th, okay? And these are perfect because when we have a 4th root, we take the exponent and we divide it by the number in the crack, and that's how we get our answer of x. All right, same thing here. When we have x to the 8th underneath there, it's perfect because we have a 4th root and we divide the 8 by the 4 and we get x squared, and so on. Okay. Oops. All right, so let's take a look at our list of numbers. And let's take a look at our examples down here. And it says express each of the following in simplest radical form. Okay, and so you're going to notice that these are different than the ones on the front because these are not square roots, these are cube roots. Okay. All right, so here we go. When we simplify and we break them up, now you have to remember to put that 3 in the crack there. Okay, and you also have to look at your list of perfect cubes, okay, which is up here. You guys can see them on your notes, hopefully. I can't see them on mine, all right, because they're up there. But we're looking for the largest perfect cube that goes into 108, not the largest perfect square because we don't have square roots, okay? So be careful. So we have looking at our numbers. Since we have 108, we're looking at 64, 27, or 8 to be the largest number that goes into 108. And the largest winner is 27 on the list. 27 goes into 108 4 times. So 27's in the first house because it's a perfect cube. 4 is the remaining number in the non-perfect house, okay? All right, now that 108 is split up, now we have m to the 6th. Okay, 6 is an exponent, not a coefficient. And so 6 has to be divisible by the number in the crack. And it is. 6 is divisible by 3. And therefore, m to the 6 is considered a perfect cube. And so he does not need to be split up. He can go right and live into the perfect house. Now that everything has been divvied up, okay, into perfects and non-perfects, we go ahead and take that perfect cube house, okay, which I always write first. And now we're going to look at the cube root of 27. If you have your list, you can take 27 and follow it back to see what you cubed to get it. Or you could type the cube root of 27 right into your calculator, okay? Our cube roots are under our math menu, all right, if you need them. And the cube root of 27 ends up being 3. And m to the 6, right? The exponents have to be divisible by the number in the crack. And so 6 divided by 3 is 2. And so we get m squared. And we take this cube root with the 4 in it, and we just bring it down. And there's our answer. Okay? Be very careful, guys. The number in the crack, okay? Make sure that he is right in that crack so he doesn't get confused with the 2 that's on the m, okay? It's very often that people will misread the exponent on your variable there as the number in the crack. So you'll notice that I leave a little bit of a space in between what is on the outside and then my cube root, okay? And I do that on purpose so it doesn't look like a number sitting on top of a number, okay? All right, so number 11, we're going to go ahead and break that up since we have to simplify that radical. Okay, make sure you put the 3's in the crack so you know that they're cube roots, not square roots. And we have a negative number underneath there, and that is okay to have a negative number underneath an odd radical, all right? So a cube root is an odd number there in the crack, so it is okay to have that negative 128 under there. So we're just going to focus on 128 for now, okay? And we're going to find the largest perfect cube that lives under it. So we got to go ahead and look up and look at our list. And we are looking at the numbers of 1, 25, 64, 27, and 8. And the largest number that goes in is 64. And because we do have this negative underneath here, it will always go and live in that perfect house, okay? So we're going to have a cube root of negative 64. Negative 64 times 2 will give you that negative 128. So now we have that broken up. We're going to look at x to the 8th. All right. Remember that this exponent has to be divisible by the number in the crack, and 8 is not divisible by 3. So we go to the next lower one, which is x to the 7th. 7 is not divisible by 3. So we have to go to the next lower one. So we go x to the 6th now. And x to the 6th is divisible by 3. So we're going to do x to the 6th. Okay. Leftovers would be x squared, because remember, you add your exponents, okay, when you're multiplying here. And 6 plus 2 is 8. All right. Now that everybody has been divvied up, we go ahead and we circle our perfect. Okay. And the cube root of negative 64, well, the cube root of 64 is 4. So the cube root of negative 64 is negative 4. And if you didn't know that, you can ask your calculator, okay? The cube root button is under your math menu, okay? And we're going to go ahead and do the cube root of x to the 6. Remember that 6 is an exponent, gets divided by the number in the crack, okay? And you're going to get x squared. All right. And then we're going to go ahead and we're going to bring down our cube root house of 2x squared. A common mistake is you guys will forget to put that 3 in the crack, okay? So make sure that you do, because if you don't bring that down, then you're saying it's a square root of 2x squared, which is a lot different than the cube root of 2x squared, all right? So be careful. All right. Again, guys, you'll notice that I leave a little space there between what is outside and my cube root. Number 12. All right, so this time, guys, we have that negative 2/5 on the outside, so we're just going to leave it there. And we're going to go ahead and break this up into 2 cube roots, okay, being the perfect and the not perfect. All right, we have 250, so we're going to go ahead and look at our cube root list, which is up here. Okay. And we're looking at the numbers of like 1, 25, 64, 27, 8, and the largest perfect that goes into 250 is 125. And it goes in twice. Okay, now we're going to look at x to the 5th. And 5, our exponent, is not divisible by 3. So we're going to go to the next lowest, which is x to the 4th. And that's not divisible by 3. So then we're going to go x to the 3rd, and that is divisible by 3. So we're going to put x to the 3rd here, and the leftovers, which would be x squared, here. Okay, now we got to look at the 9. All right, 9 is divisible by 3, so we don't have to split it up, and it can go right and live in the perfect house. Okay, and now we have z squared, and that 2 is not divisible by 3. And if we go lower, 1 is also not divisible by 3, and we can't go any lower. So therefore, z squared can never be simplified into a perfect and a not, so he's kind of forced to live in the non-perfect house. Okay, and now that everybody has been split up, we go ahead and circle our perfect house, okay? So the cube root of 125. Again, look up at your list and follow 125 back, and you're going to realize that it was made by 5 cubed, and so the cube root of 125 is 5. Or you can use the button in your calculator in your math menu and take the cube root of 125. Okay. Remember that your exponents are divided by the number in the crack, and so that's going to give you an x to the first or just an x. And then our exponent of 9 divided by the 3 in the crack will be y to the third, because 9 divided by 3 is 3. Okay. The non-perfect house just comes down. And our -2/5, we can't forget about it, also comes down. Okay, and multiplication goes in between. And -2/5 times 5, you can do that in your calculator. Okay, it's just -2. And that'll be an x, a y to the third. Leave a little space. You got a cube root of 2x squared z squared. And this is finished. All right, so you have to be very careful when you break them up, okay? Make sure nobody disappears. All right, let's take a look, guys, at the next 3. Oh, okay, so they changed it on us now. We just have to do the same thing and apply just using a different list of numbers. All right, so now these are 4th roots, so we have to make sure we're looking at the 4th root list. Okay. All right, so here we go. Make sure there's a 4 in the crack this time. And make sure you're using your list of perfect 4th roots. So we have 162. And so 162 has options of 81 or 16, which is nice. So you got less numbers to choose from. And the largest perfect 4th root that goes into 162 would be 81. So 81 lives in the first house, and it goes in twice. 81 times 2 is 162. Okay. And now we're on to the exponents. Okay. Just remember that the exponents have to get divided by the number in the crack. And 8 is divisible by 4, and so it's considered perfect, and we don't have to break them up, and he goes right in the perfect house. Okay. And now we have y to the third. 3 is not divisible by 4. If we go lower, 2 is not divisible by 4. Okay. 4 is divisible by 2, but remember, it's 3, the exponent, divided by the number in the crack. So 3 divided by 4, nope. 2 divided by 4 is a decimal. 1 divided by 4 is a decimal. And so we can't break up y cubed. Okay, so therefore he's forced to live in the non-perfect house. And everybody's been broken up, so we go back and we circle our perfect house. And now we need the 4th root of 81. Common mistake, people will take the square root of 81. And that's why it's important to put those 4s in the crack, so you guys remember that it's the 4th root of 81, not the square root of 81. Okay, if you have your list of numbers, you could just take 81 and follow it back and realize 81 was made by 3 to the 4th. So the 4th root of 81 is 3. All right. Remember that the exponents have to get divided by the number in the crack, and so that's going to be x to the second, because 8 divided by 4 is 2. Okay. And we leave a little space, and we bring down our 4th root of 2y cubed. Make sure that 4 is in the crack, okay? And that one is done. All right, let's take a look at 14. All right, so we got 4th root again. So we'll go ahead and do our perfect 4th root house and our not perfect 4th root house. And we have the 48. So we go to our perfect 4th roots up at the top. And 48 is a small number, so we only have actually only one option. Hopefully it's 16 that goes in, because remember, 1 doesn't count and 81 is too big. So 16 is our winner, and it goes in 3 times. So 16 will live in the perfect house, 3 in the not, because 16 times 3 is 48. Okay, so now we're on to the variables with the exponents. And remember, 10 has to be divided by 4, and it's not. Okay, it's not divisible by 4, so we go to 9. 9 is not divisible by 4, so we go to 8. 8 is divisible by 4, and so we go x to the 8th. The leftovers, which would be x squared, go in the not perfect house. Okay, and now we're on to 5. 5 is not divisible by the 4 in the crack, so we go to the next lower one, which is y to the 4th, and that works. And so we'll have y to the 4th in the perfect house, in the leftovers, which is y in the not perfect house. Okay. We're going to go up. We'll circle our perfect house. And the 4th root of 16, if you look at your list up there, okay, is 2. A lot of people say 4, all right, because they're thinking square root of 16, but it's the 4th root of 16, okay? And then we're on to our exponents. We have 8 divided by 4, so that's a 2, so that's x squared. And when we have an exponent of 4 divided by the 4 in the crack, which is 4 divided by 4 is 1. And so y to the first, or just y. All right, we bring down, leave a little space there, and bring down our fourth root of 3x squared y. And we box them up, and this one's finished. Okay. All right, so now 15. Now, we didn't make a list of perfect fifth roots, but if I were doing this, okay, and I needed that list to look at, I would just generate them myself. So 1 to the fifth is 1. 2 to the fifth is 32. 3 to the fifth, okay. 3 to the fifth. Let's see, I don't have that one listed. So I'll just use my calculator. Okay. 3 to the fifth is 243. So we can even stop there. We didn't even need that one, but they can keep going, okay? And then remember that your variables have to be divisible by 5. So x to the fifth would be a perfect, x to the 10th would be a perfect, x to the 15th would be a perfect, because those numbers are all divisible by 5. All right, and they can keep going. All right, so we're going to go ahead and divvy him up into a perfect fifth root and a not perfect fifth root. Make sure those 5s are in there. And we only have one choice to break 64 up into, okay, and that is 32. And 32 times 2 is 64. So the number's done. And now we're on to the variables, okay? So 12 is not divisible by 5. So we go to x, so we go to 11. 11 is not divisible by 5. So then we go to 10. 10 is divisible by 5, and so we go x to the 10th. The leftovers, which would be x squared, go here. All right, now we're on to y to the 15th. 15 is divisible by 5, and therefore it's considered perfect and does not need to be broken up. Okay, now that everybody's been divvied up, we go and we circle our perfect, and we go to the fifth root of 32, which we can do in our calculator, or if we already generated our list, we take 32, we follow it back and realize it came from 2 to the fifth. And so the fifth root of 32 is 2. Okay, now on to our exponents. All we have to do is take 10 and divide it by 5, which is 2, and so we get x squared. And then we take 15 divided by 5, which is 3, and we get y to the third. Okay, leave a little space and bring down that fifth root of 2x squared. Box them up. This one's finished. All right. So they're very procedural in that we do them the same way. We just have to apply how we break them up to whatever number is in the crack. Okay. All right. Let's go ahead and take a look at some of these. Okay. Now, we've done and been working on these for a long time. We just have to realize that what we've been doing, we put sometimes in radical form, but never simplest radical form because we didn't know how to simplify them until now. All right, so in number 16, hopefully looking at this problem and what we've been doing in the past, you realize that the top is going to stay x cubed, but the bottom needs to be rewritten, okay? We don't have rules for radicals, so we're going to change them to a fractional exponent of x to the 1/2. All right, because the square root of x is the same thing as x to the 1/2. But now that we wrote it like this, we can take our exponents because our operation is this division. We subtract our exponents. Okay, so 3 minus 1/2, okay, is 2.5, and if you math fract that, that is x to the 5/2. All right, so that's what this equals. And because it says simplest radical form, we're going to go ahead and transform him back into a radical now that it's been simplified. 2's on the bottom, 2 goes in the crack, and then x to the 5th would live under here. And normally in the past, we would box this in and call this our answer. However, it is actually not in simplest radical form because 5, the exponent, is not divisible by 2 in the crack. Okay, so we're going to break them up like we just taught. 5 is not divisible by 2, so we go to the next lowest, which is 4. 4 is divisible by 2, and so we get x to the 4th in the perfect house, and then the leftovers of x in the not perfect house. Okay? We go and we circle our perfect, okay? And 4 divided by 2 is 2, and so we get x squared on the outside, and then on non-perfect of the square root of x comes down. And again, you don't need that 2, but I know a lot of people are going to want to leave it there. And it does not matter to me if you leave it there or don't leave it there, okay? So it all depends on your comfort level, okay? If you can better understand the question by leaving the 2 there, you leave the 2 there to get the right answer, okay? All right, 17. So again, hopefully you know, guys, to rewrite this. Remember, there's a 2 in the crack when you don't see a number, and that number in the crack goes on the bottom. So we would say x to the 5 halves is what the top is equivalent to. On the bottom, we'll leave it as x to the 4 thirds. And now that we have exponents, we know that when our operation is division, that the exponents get subtracted, and we throw them right in our calculator. So in our calculator, in parentheses, 5 halves, minus, in parentheses, 4 thirds. If it comes out as a decimal, you math frac it, and we end up with x to the 7/6. Okay, because our directions are talking about radical, now that that's been simplified, we go back and we change it so the number in the crack would be the 6, and x to the 7th would be underneath. And normally we would box that up, but now that we know how to simplify them, we're going to go ahead and say that, hey, this 7 is not divisible by that 6, so we're going to go ahead and break it up. Okay. 7 is not divisible by 6, so we go lower, and we go 6 divided by 6 is. So we go x to the 6th in the perfect house, the leftovers, which would be x to the first, or just x in the non-perfect house. We go ahead and circle our perfect. 6 divided by 6 is 1, so this is just becomes x to the first, or just x. And we leave a little space and bring down that not perfect house. And there's our answer. Okay. All right, let's try 18. A little bit different than those two. But we've also been working on this, where that 2 thirds here needs to be used twice, once on the numerical base and once on the variable base. And so we're going to rewrite this as 8 to the 2 thirds and x to the 5th to the 2 thirds. Okay. In our calculator, we can go ahead and type in 8 to the 2 thirds, and 8 raised to the 2 thirds is 4. Okay. When we have an exponent raised to an exponent, remember that the operation is to multiply those exponents. So 5 times 2 thirds is what we type in our calculator, and we end up with x to the, if it's a decimal, math frac it, and that's 10 thirds. All right. And normally we would box that up, but because the directions say radical form, we're going to go ahead and rewrite this part of it, x to the 10 thirds. Okay. But the 4 is going to stay outside the radical because it's not raised to the 10 thirds. And 3 is on the bottom, so 3 gets the crack, and x to the 10th would stay underneath. Okay. And again, normally we would box that up as our answer, but now that I showed you how to simplify radicals, we can put this in simplest radical form instead of just radical form. So the 4 stays, and we're going to break this up into a perfect cube root and a not perfect cube root. Okay, 10 is an exponent. It's not divisible by 3. So 10 divided by 3 doesn't work. 9 divided by 3 does work, though. So we're going to change this to x to the 9th, and then the leftover, which is x to the first, or just x, goes in the not perfect. Now that it's been divvied up, we circle our perfect, okay, and we divide our exponent by the number in the crack, and we get x to the 3rd. We bring down our 4, and we bring down our not perfect cube root house of x. And that is finished. All right. So it does take some time to simplify these. All right. Just make sure you don't make anything disappear. Make sure everything is equivalent to the step above it. All right. All right, guys. I will see you guys on the next day of notes.